I'm going to describe how to apply k-means clustering to company data using Python. Here you can see a plot showing the output of the k-means clustering analysis with 5 clusters. I downloaded the company data from Kaggle. Pip installed scikit-learn, pandas, matplotlib and need. I imported the packages. I loaded a financial data CSV file into a pandas frame and selected stock ID, cash ratio and debt equity ratio fields. I cleaned the data by ensuring cash ratio and debt equity ratio were float values and dropped any null values. As the k-means clustering algorithm is sensitive to scale of features, I standardized the features. So cash ratio and debt equity ratio would have the same scale. I set up the k-means algorithm arguments. When the k-means clustering algorithm begins, the centroids for each cluster will be randomly assigned. As k-means clustering can produce different results depending on how the centroids are initially assigned, we'll run the algorithm 10 times and select the clustering which produces the best results. When we first begin the analysis, we don't know the optimum number of clusters for the dataset. So here we have a loop ranging from 1 to 11, where we try different values of k for clustering, and storing inertia, which is a measurement of the quality of the clustering, and seeing which cluster best matches the data. Sum of square errors from each cluster centroid is a measure of the quality of each cluster. The smaller the sum of square error, the better the clusters. Here we're plotting the number of clusters against the sum of square error. As we increase the number of clusters, the sum of square error reduces. Eventually, the rate of reduction slows down. Around 5 to 6 looks to be the optimum number of clusters, and this is described as the elbow. You can also work out the optimum number of clusters using code. Here we're using NeLocator with the range of clusters and sum of square error, and we're printing out the elbow, which is 5, which is the proposed optimum number of clusters for this dataset. Using the elbow value of 5, we then refit the k-means cluster to the data points. We can then get the labels for the companies. These are the clusters to which each company has been associated with. We'll then plot the features, cash ratio and debt equity ratio for each cluster. Here the color is influenced by the number of the cluster. You'll notice that some of the clusters have very few members. I'd recommend you doing analysis to check whether these values are outliers, as outliers can influence the quality of cluster produced. Here for the 5 clusters, I'm printing the number of members of each cluster. And I'm also printing the stock ID and the associated cluster it's a member of. You can also create new data points and predict to which cluster they would be associated. Here I'm setting up a new data point with a cash ratio of 0.6 and debt equity ratio of 1.2. I'm scaling the data and then calling predict. The prediction indicates that this data point would be in cluster 2.